Hey everyone and welcome. Today we're going to take a deep dive into two amazing things: the incredible little machine that is your eye and the breathtaking optical wonders of the world it lets you see. Let's get right into it. So it really all boils down to this one question. How in the world does this tiny organ, barely an inch across, manage to capture everything? The whole vast, colorful world around us, from the tiniest print on a page to a mountain way off in the distance. It seems almost impossible, right? Well, that's what we're here to unpack.
You know, the easiest way to think about your eye is as a super advanced living camera. It's constantly taking in light, focusing it, and turning it into signals your brain can understand. And it does all of this in a literal instant.
And just like a high-end camera, it has all these amazing parts working together perfectly. The cornea is like the main outer lens, doing most of the heavy lifting. The iris and pupil, that's your aperture, opening and closing to control how much light gets in. The crystalline lens is for all that fine-tuning focus. And the retina, that's the sensor at the back, the light-sensitive screen where the image forms. Then the optic nerve zaps all that info straight to your brain. It's an incredible system. Okay, let's zoom in a bit on that lens, because this part has a genuine superpower. It's something that even the fanciest, most expensive cameras struggle to replicate perfectly. It's called accommodation. So what is the accommodation? It's your eye's built-in autofocus. It's the amazing ability of the lens to literally change its own shape. This is how you can be looking at your phone 1 second and then glance up and instantly focus on a bird flying across the sky, all without even thinking about it.
So how does it actually pull this off? Well, when you look at something far away, these tiny things called ciliary muscles relax. This allows your eye's lens to flatten out and become thin. But to see something up close, those same muscles contract. They squeeze the lens, making it thicker and more curved. This constant, subtle change is happening all day long, letting you shift focus in a blink.
Of course, like any complex piece of machinery, sometimes this incredible autofocus system isn't perfect. And this leads to some really common and thankfully very correctable issues with our vision. First up is myopia, which you probably just call nearsightedness. What's happening here is that the eye is focusing light a little too much, or maybe the eyeball is just a little too long. The result is that the image of distant objects gets focused in front of the retina, not on it. So anything far away looks blurry, but stuff up close is perfectly clear. And on the flip side, you've got hypermetropia or farsightedness. It's the exact opposite problem. Here, the eye's lens doesn't have quite enough focusing power, or the eyeball is a tad too short. So the focal point for things up close ends up falling behind the retina. And this makes things like reading a book a real strain. So if the eye's focus is just a little bit off, how do we fix it? The solution is so elegant and has been helping us for centuries. We basically just give our eye a little help by putting a second lens right in front of it. So to fix myopia, that nearsightedness, we use what's called a concave lens. This lens spreads the light rays out just a tiny bit before they even hit your eye. That little bit of divergence is the perfect correction to push the focal point backward so it lands exactly on the retina. Simple as that. And for hypermetropia or farsightedness, you guessed it, we do the exact opposite. We use a convex lens, which is thicker in the middle. This gives the light rays a little extra focusing power, pulling that focal point forward so it lands right on the retina where it belongs. Problem solved. Okay, so we've got a handle on the lens inside our eye. Now let's zoom way out, because the exact same principles of how light bends and focuses are responsible for some of the most jaw-dropping displays in all of nature. The magic word here is dispersion. It was actually Isaac Newton who first figured out that plain old white sunlight is really a mix of all the colors of the rainbow. And when you pass it through something like a prism, the light splits apart because each color bends at a slightly different angle. Red bends the least, and violet bends the most. And a rainbow? It's just nature's giant demonstration of dispersion. Every single tiny raindrop acts like a little prism. When sunlight hits a raindrop, it bends and splits into colors. Then it bounces off the back of the drop and bends again as it comes out, sending a perfect little spectrum of color right to your eye. When millions of drops do this all at once, you get that beautiful arc in the sky. Okay, that explains rainbows. But it brings up another huge question, right? If sunlight contains all the colors, why does the sky look blue on a clear day? Why not green or yellow or just white? The answer is something called atmospheric scattering.
See, our atmosphere is full of tiny little particles of gas and dust, and it turns out these particles are way better at scattering shorter wavelengths of light, like blue and violet, in every direction. Longer wavelengths, like red and orange, they just tend to pass straight through. So when you look up at the sky, you're seeing all of that scattered blue light coming at you from all directions. And get this is also why sunsets are red. When the sun is low, its light has to travel through way more atmosphere to reach you, so most of the blue light gets scattered away, leaving those beautiful reds and oranges to come straight to your eyes.
You know, we've talked about all the amazing physics and biology that come together to create this colorful world for us. But the ability to actually see that world is a profound gift. And it's a gift that, believe it or not, doesn't have to end when we do.
It's an incredible thought, but through eye donation, just one person, a single donor, can restore sight to as many as 4 people who are suffering from corneal blindness. It's this incredible legacy, a gift of light and color, passed from one person to 4 others.
And that really brings us to our final thought. We've seen how our eyes work and how they perceive this vibrant, colorful world around us. But maybe, just maybe, the most colorful thing of all is the chance to give that world to someone else. Thanks for joining me.